refactoring.
Huh?
Refactoring.
What
refactoring?
Oh, refactoring. Oh, I didn't know. Yes. Guys, there's drinks there. There's beer. There's iced tea. If you want, yeah.
Paano kung pwede ma-export yung box for deployment or loan? Yun naman talaga yung vagrant, ganun. Pwede mo yung pati Docker.
So before I start my talk, I'm very happy that there are so many attendees for tonight's event.
Microphone.
So I'm happy that there are many attendees for tonight's meetup. So I see many new faces. So I hope that you're going to attend more in succeeding meetups. So I'm Norman Ancajas, and my talk for today is about refactoring the Gilded Kata. So first, can you please show of hands of who among you here are familiar with the Gilded Kata? Okay, so actually that's a lot better because we're gonna walk through the code basically and do some refactorings, have some ideas about how we design our software. So I think this one is you can. I hope that you can have some inputs on, especially in helping you grow as a developer. Yeah. So first off, need to define what is the Gilded Kata. So I know it's a big question mark. For this slide, I didn't want to put a boring description about the problem that we actually want to address or want to do. So I'll just walk through the code. So if you can please follow me and just let's see where it will end up. So for the Gilded so basically this is the format. So this is the class. So you have the constructor. So basically it takes three parameters. So just the name, the quality, and the base remaining. So based on this one, you have the idea that it's something like an inventory system, part of an inventory system that tracks the quality of a specific item and also tracks the days remaining, or basically the days remaining before it will expire, something like that. So just let's just keep it vague and then. So aside from that, we have the method tick. So the idea of the method tick is that this is the one that you actually run periodically, and based on those attributes, you will mutate your data based on those attributes. So yeah. So this is just the first part of the code. So can you notice anything about the code?
It's like
It's more nice.
Yeah, it's not really the nicest piece of code that you really want to edit, right? Like for now, it's safe to assume that we know that it just works. So that's the first, I think, 24 lines. And this is the next 21 lines. So this is the second part. So that whole method is, I think, 42 lines. 40, I don't know. So yeah, so that's the method. So imagine, for example, that you're a developer and you don't have the requirements and you're asked to do something about this code, and then someone just, someone explains it to you, and when it justifies how the code got into that kind of state, sometimes it gets to the point that all you hear is just a blah 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 blah. So yeah, so well, it's really difficult to make your hands dirty when you try to do some changes on that. So yeah, one of the few examples that you can do to test if the code is really what do you call this, very easy to understand is to do the screen test. So when you do a screen test, you cannot really get a general idea of what it does, right? It's very long. It's very nested. And for this one, the colors. If you see the colors, it's you should see the structure or general idea of the structure of the code. So you really have many conditionals. So for this one, I have 16 if statements, 7 what do you call this? Negative conditional, negative inequality, 2 negative inequality with ampersand, double ampersand, and 3 magic strings. Can you see the magic strings? So it's all littered across the full scope of the code. So these are your magic strings. So Aged Brie, right? So Sulfura, Sand of Ragnarok. I mean, I don't even know what that means. So and backstage passes to after 80C concerts. So yeah, but the good thing is that it has tests. So let's try to run the tests. So 31 runs, 50 assertions, 0 failures, 0 errors. That's important, but you have 6 skips. So I want you to take a mental note about that because that's actually what we're trying to change. We want to run the test so that there won't be any tests that are skipped. So this is the look of the tests that you have, and you can see certain parts of the test. So this is one is the checking your Brie, the Brie. This part of the magic string. Second, sulfurous. Wallet magic. That's the point. So and third is backstage pass. Weird thing is that I have normal. I have test for normal items, something like that. So really, it's kind of surprising that you have that. You need to check for that one, but it's not part of the magic strings that you have in the chapter that you have earlier. So yeah, let's take a look at the test for the first one. So you have this test. So you instantiate the Gilded rows. So you pass in the name, the quality, and the days remaining, and you run the pick method. So what does it actually do? So you have the test that after you run that, you check the attributes of the Gilded rows object that you have. So from here, it's very easy to deduce that you just subtract by 1 from the quality and the days remaining. So yeah. So this one, this is the test, the Conjured test that is actually not part of the magic strings that we have. So remember the 6 skip test. So this is the one that it's not implemented. So our task really is how do we implement Conjured? I mean, do you think it's possible based on the method that we have? So for me, it's really like this. I mean, it's like shooting yourself in the foot. In this case, you have a talent goes and then nuke your own base just to solve your problems. So I think this is really out of the question. So what we do is we refactor our code so that we can implement Conjured. So what I'd like to do is I first want to trap that specific item, for example, the normal item, and then I'm gonna do my implementation there and keep the tests passive. So here I put in sort of a simple trap. So first I just check if the item name is normal. So I run my tests. So I get 4 failures. So basically these are the tests that check for that specific item. So yeah, what do I do? So I put in a normal tip, another method. So this is the one we checked earlier. So I just subtract one from both attributes, the item quality and the days remaining. So I run my test, I get 3 failures. So that's a good thing, right? So I get that test out of the way. So I now proceed to the next test, which is test normal item of 0 quality. So, this different. So test normal item on selfing. So what actually does is tests the item when the days remaining is 0. So that tells me that that is the selfing. So I just check that if the attributes of my item is already on that state. I just check that it will subtract 2 from my quality attribute, and same thing, just subtract 1 from the days remaining attribute. So here's my implementation. Can you see the? So here's the implementation. So first I just check if the days remaining is greater than 0. So this is the part of the code that we want to maintain in order to pass the first test that we implemented earlier. So, but the second if condition makes this specific test pass. So just subtract it -2 when the days remaining is less than or equal to 0. So I'm surprised because I only got 1 failure. Remember that before we have 3 failures, right? So this gives me a confidence about my code that it actually solved a case that I didn't take into account for. So for this one, I'm not even gonna take a look at that which test it actually passed. So from 3 failures, only got 1 failure. So this is the last succeeding test for the normal item. So test normal item of 0 quality. So what does it actually do when the quality attribute is already 0? So based on this one, I won't do anything with the quality attribute, and then just have my days remaining, same thing, decremented by 1. So I change my code, and then I put in a condition. Just checks if the quality is not equal to 0. It's going to do all those data mutations that we did earlier in order for the test to pass. Aside from that one, no change. So yeah, 0 failures. Next step is this code is not really the best looking code. That I think we can simplify this more. So what we do is after we get all the tests passing, and after we introduce our changes, we refactor under Brie. So what we does is name a similar name, put a similar name method and then put a changes there. So from here you can see that I just do the same thing with the daisy remaining, regardless of the data, the state of the data that I have. So I just put it there, daisy remaining minus equals 1, and I put in a condition that it just return if the quality is not equal to 0. And here's the one, make it more simplified. Quality, I subtract -1, and then I subtract another. I subtract again if the daisy remaining is less than or equal to 0. So yeah, we remove all that that previous code, then run again our tests, and then pass again. So we already have the normal item out of the way, so I guess we can proceed with the next item. These are the tests for Brie. 1, 2, 3. So from the if conditional statement, it's probably better to introduce a case, switch case or case when statement, which just checks what the name of the item is, and then just in they just call the respective methods that correspond to that item. So if I run my test, I get 7 failures. So we're not really gonna do it what we did earlier. So I'm just gonna fast forward. This is the implementation for the Brie peak. We run again our tests, passes again. So yeah. From here we can see similarities about our refactored code. But I say duplication is far cheaper than the ROM abstraction. Sometimes there's a certain point that you have to know that when to do the refactoring, or first do what you've done partially, then complete it, and then after that, that's when the good time is to do the refactoring. So I think from this point on, we're just gonna trudge on and then just do the refactoring for the remaining items. So I have the sulfurous item. I only have 3 tests. So I do again the trap, put a trap in for that item. But when I run the test, 0 failures. So it does nothing. So it's not really that apparent when we took a look at the long method earlier, but based on the test, it basically just does nothing. Yeah, so we got that out of the way. So backstage, this series of tests. This is the implementation that we get the tests passing. And then my tests, 0 failures again. Just a recap. This is what our method looks like. I think it's safe to say that you can just remove that part of the code, right? Since we've already taken into account our refactoring to trap the items, to trap all the items that we take for this series of tests. Just to be sure, I'm going to test, so 0 failures. So, yeah, small methods are simple. I think this one is really, I think we should really put more emphasis and, making our methods as simple as possible. So, this is the one that the right side, the one that we factored, and the original method on the left side. I think, would you agree that it's more readable? So yeah. So I did some refactoring, so probably I can implement Conjured now. So this is what our methods look like, small methods look like. So I have implementation of normal tick, creating, so for us, backstage, Conjured. And when introducing the Conjured tick, is it really the best solution? So it seems to me that it's not really the best case to do for this particular problem, because I think we can leverage more of the open close principles. So it's more of an OOP pattern that keep your you should be open for extension but closed for modification. And the rationale about regarding that one is that when you change an existing code, it really introduces it lets you be more closer to introducing bugs to your code than just implementing or than just by extending the existing code that you have. So what I do is this is actually what I think we can really put those several items into their own particular objects. So I put in an initializer. So instead of the whole conditional, I just instantiate the normal class and then just run the item key. So fast forward, I do that for all the remaining items. So I think for this one, I can just remove all those calls to the normal tick, and then I just put it in the case when statements for all items. For this one, it seems to me that it's not really a good idea to put all those instantiations in the tick method, so it's probably better to have the class instantiation in the initialize method. So instead of just assigning attributes, I remove that one and then substitute it to the item. How do really I do that? So I take this code right here, just put in a question mark and then just run a .new or initialize them, those classes. So I identified some of those, some of the repeated code that I have. So instead of calling it the tick method, I change it to class code. So if you can see the question mark, we're now calling for the class for which instantiates the correct item. And then, so yeah, I introduced also these methods for this object. But it seems that there's really something going on with what our idea of is regarding the Gilded goes, what it really is. It seems like you just have to, this is just a use case that I need to instantiate an object. I pass this, the name, I expect it to be a rows, Gilded rows object. But what it really does is it's just an item factory. And you just use it to instantiate several different items. So what you actually do, instead of instantiating it, you introduce a class method, change it to self-refer, change this one also. Instead of having a reference to that item, change it to, you call the class form method, then remove that attribute feature, the second one. So when I take a look at this set of methods, they're acting just like a middleware. So I think it's safe to remove that one. And then I'm going to take a look at the refactored class normal. Yeah. I observed that there are there are some repeated code that I have, especially in initializing. So I guess it's safe that I can just put it in another class. I inherit the item class, put in the initializer in the item class for the association, and I just put in the tick method for the respective items that I have. So inheritance, I mean, it's not either. We have this notion that we need, based on design patterns, that we have to favor composition over inheritance. But actually, in this case, I think inheritance is not even, programmers are. So yeah, so item quality days remaining. I think we can move that to the parent class. Then remember the sulfurous item that we have earlier. I think we can introduce more we don't really need to instantiate sulfurous, or we don't really need the sulfurous class. This one we just replace it with the item class, because it basically does nothing based on our tests. So we remove that one, and here there's something really, I mean, when I see this code, it's not really, I mean, there's something telling me that this part is wrong. I mean, you check the name of the item, and you have several when statements that when it's normal, you return the normal class. So I think we can improve this one. So I think we can extract configuration. So for this one, I introduced two constants. I have default class, which is item, and I have specialized classes. So this is just a hash. The key are the magic strings that we have, and the values are the classes that we define. So the class for the class form, we replace the method inside with the instantiation. So I check first if it's present in the specialized classes, but if not, it's just going to use the default class. So notice here that we don't have the sulfurous, so that's we intended that we have this conditional statement. Once we get the class, we instantiate it, and then pass it the quality and the days remaining attributes. So yeah, small objects makes our code really readable. So this is what our code looks like right now. We have the class item, and then you have the succeeding classes or the items we inherit from that original parent class. The backstage are part of the instantiating our classes. It's small objects. So this is the left one is our first look on the thick method. The small method is the one, so intermediate step that we did, and then compare it to the small, on the right side, the small objects. So yeah, I guess right now we can implement Conjured. I think it's a lot more easier, right? So this is what our code should look like. We just create a class, inherit from item. This is the implementation for the thick method. And this one, we just add it in the specialized status constant. That's passive. Yay. So this talk is actually just based on sentiments, all the little things. If you want, you can rewatch all the talk that we did now. She does a lot more better in explaining that, so probably just search it and watch it. So this is the part that I have to segue on introducing our company, basically, Overthrow Technologies. So unofficial background. So founded in 1842 by Mr. Overthrow. So I used our reference PowerPoint. That his occupation was master printer and lithographer. So I don't really know what that is. So, but in 1982, some guys, entrepreneurial skills out of the company that expand its business. So, right now we have several business units, so payments, LFD, NFC, telecoms, yeah, telecoms. So just to give you a background, so the Philippine passport, the brown passport with NFC chip, that's part of our solutions, and also the Philippine money.
Yeah, bills printing.
Bills printing, the new design, that's part of our business, right?
Sure.
Yeah. Actually, I'm not really familiar with all of the business of Overthrow because
This
we
is
are.
what a blank SIM card looks like.
Yeah. Yeah, Vic is working on the
Mobile.
mobile. Yeah. So yeah, so we strive to write readable code, and we're hiring. So if you want to get more in touch with that attitude that we don't just care whether we implement features, we take into account our, how we actually write those features. We're hiring. Thanks. Any questions?
All right, thank you, Norman. So, yeah, so I guess this is, we're finished. Yeah, the program is finished, but you guys can still stick around, and there's still beer, there's still food. Yeah. Yeah, so thank you for coming tonight. Yeah. See you next month.